Alright, so here we have a question about sequences. So, namely, I'm given the Lucas sequence, which I'm told L of 0 is 2, L of 1 is 1, and the next term is the sum of the two previous terms. And then I'm given the Fibonacci sequence. I want to show that the nth term of the Lucas sequence is the n minus 1 term of the Fibonacci sequence plus the n plus first term of the Fibonacci sequence for n greater than or equal to 1. So to solve this problem, we're going to use induction. So the base case, we're actually going to use strong induction here. Base case, there's actually going to be two of them. There's going to be n equals 1 and n equals 2. So these are our two base cases. I'm just going to write out a couple terms. So I'm going to have L of 0 is 2, L of 1 is 1, L of 2 is going to be 3. Fibonacci sequence, f of 0 is 0, f of 1 is 1, f of 2 is 1, f of 3 is 2, and I think that's all we need. So for n equals 1, L of 0, or L of 1 is equal to f of 0 plus f of 2. This is true. L of 1 is 1, and that's equal to f of 0 is 0, f of 2 is 1. N equals 2. So this would be saying L of 2 is equal to f of 1 plus f of 3. This is true. Let's look at what I wrote down. L of 2 is 3, f of 1 is 1, f of 3 is 2, and that is 3. So the base case holds. So the inductive hypothesis assume for all k less than or equal to n that we have that this holds. That is, L of k is f of k minus 1 plus f of k plus 1. So that's that's the inductive hypothesis. And then the inductive step. So here we want to show this is true for n plus 1. That is, so what we want to show is we want to show it's true for n plus 1. That is, we want to show that L of n plus 1 is equal to f of n plus f of n plus 1, or f of n plus 2 in this case. That's what happens. And sure, here's how we're going to do this. So the idea is we're going to use this here. I'm going to call this star. So I have that L of n plus 1 is equal to, this is by star, L of n plus L of n minus 1. Okay? Now we're going to use our inductive hypothesis. This is equal by the inductive hypothesis, and this is why we have to assume for all k less than or equal to n, because n minus 1 is in that k. So here, well, L of n is going to be f of n minus 1 plus f of n plus 1. So this here is like L of n plus, we have to have the L of n minus 1 term. So this is going to be our L of n minus 1 term. So this is going to be f of n minus 2 plus f of n. Now, here's what I'm going to do. I'm just going to rearrange this sum. I'm going to say this is just equal to f of n minus 1 plus f of n minus 2 plus f of n plus f of n plus 1. So I just regrouped my sum. So, and now I'm going to use this, which I'm going to call double star, and in line with this. So this is equal by the double star to exactly what we wanted, f of n. So this here, this is going to become f of n, and this is going to be f of n plus 2, plus f of n plus 2. And that is exactly what we wanted to show in the inductive step. So we're done, and that shows that the nth term of the Lucas sequence is the sum of the two Fibonacci terms, the one coming before and after it. All right, thanks.